All right, this lesson is on simplifying square roots. On the left side shows you the parts of a radical. The left side is the index. So we'll be focusing on the index of 2, so that number won't be there, but that index will be in the number 2, so square it. And then we have the radicand, which is underneath the radical symbol. So there are two properties. There's the product property and the quotient property. So the properties in this chart are on the right-hand side. So here's the properties on the right-hand side, so you can expand them out or condense them back together. And then there's some examples in the chart below. So we're going to go ahead and move into our first example set. So example 1 says simplify the following square root. So we have the square root of 25. So the perfect square of 25 is 5. So the square root of 25 is 5. The square root of 50 now is not a perfect square, so we want to break it apart using our product property. So we say the square root of 25 times the square root of 2, and then the square root of 25 is 5, and then the square root of 2 just stays as it is. Now we have the square root of 48. 48 again is not a perfect square, so we're going to use our product property and separate out into two radicals. And then we have the square root of 16 and the square root of 3. And then the square root of 16 is a perfect square. 16 is a perfect. So that square root of 16 is 4 and then 3. So 4 square roots of 3. Example 2. 3 examples here. The square root of 216. We'll use our product property. So we'll say the square root of 36. And the square root of 6. And then the square root of 36 can reduce down to 6, and then the square root of 6 just stays as it is. The square root of 18, we break it down using our product property, the square root of 9, and the square root of 2. And then the square root of 9 is 3, and then square root of 2 stays as it is. Now the square root of 13, there isn't any numbers that we can break it apart into two radicals using our product property. Because 13 is a prime number. This number right here is prime, so we can't do anything with that, so we just leave it as the square root of 13. All right, example 3. Now notice we have some numbers out in front of those radicals. Those are coefficients there. So 5 square roots of 45. So we first separate out that square root of 45 like we've done before using our product property. So we have the square root of 9 and the square root of 5. And we simplify the square root of 9, which is 3. And then what happens is we can multiply that 5 and 3 together, giving us 15. All right, the second example, we break apart 125 into two radicals using our product property. We get 25 and 5. And then the square root of 25 is 5. And then 9 times 5 is 45. And then we leave square root of 5 alone. So again, we're multiplying this front number after we reduce. Okay, example 4. Notice now we have two square roots, and what we want to do is we want to condense the two radicals together using our product property. So if we go back up to our product property here, we can take two radicals and combine them into one radical. So right now the square root of 10 and the square root of 2, there isn't any breaking down, but what happens is if I multiply those two numbers together, 10 times 2, and I get 20, I can then simplify that back down. I can break it apart into the square root of 4 and the square root of 5. And then the square root of 4 is 2. And then we have the square root of 5. All right, next example, I'm going to go ahead and multiply 20 and 10 together. So 20 times 10, and we get 200. And then I'm looking to, again, break it back apart using our product property. So I'm going to choose 100 and 2. And now 100, the square root of 100, that's nice, perfect, is 10. And then we leave square root of 2 alone. Next example here we have 6 times 24. 6 times 24 is 144. And then the square root of 144 is 12. So we multiply then 3 times 12 together, giving us 36. All right, now we're going to use the quotient property. So if we go back up here, we have two types of properties. One is where we can take a radical and we can expand it into two radicals, or if we have two radicals into one radical. So we'll use those next. All right, so the first example is one radical, and we're going to go ahead and break it into two. So the square root of 49 divided by the square root of 81. And what that does for us is those are nice perfects. The square root of 49 is 7. The square root of 81 is 9. So you get 7/9. Next one, we get the square root of 36 over the square root of 16. And then we can notice those are both perfects. The square root of 36 is 6. The square root of 16 is 4. And we always want to reduce those fractions. We're going to divide by 2. So we get 3/2. All right, the next one here, we're going to separate it out, or not separate, we're going to combine it into one radical. So we have now 96 divided by 6. And then we're going to reduce that fraction. So 96 divided by 6 is 16. And then the square root of 16 is 4. So again, that's the quotient property. All right, our last types of problems today is to be able to add and subtract square roots. Now, to be able to add and subtract square roots, you must have like radicals. So here's what I mean. If you have a square root of, let's say, an A here, plus the square root of a B here, the indexes must be the same. And here's an index and that index. Those two indexes, the ends must be the same. So what we do is, let's say there's a number out here, like a 5 and a 4. The operation, what you do is you add the 5 plus the 4 together, and then you have n square root of b, or 9n square root of b. So I kind of just made that up. It'll make more sense once we get to our examples. Okay, so example first one. Notice in the first example here, they're both square roots of 2. So what we do is we just go ahead and add those coefficients. So 5 plus 3 is 8, and then the radical is 2. The second one, now the operation is subtraction. So 3 minus 4, I'm going to put a little parentheses there. Let me erase that here. So now we're doing subtraction. So -3 minus 4, and so let's put them in a grouping there, and then square root of 7. So now simplify that. -3 minus 4 is -7, and then square root of 7. All right. These next two are a little harder because they don't look alike yet, because they're not simplified. So what we do is we have to simplify that square root of 12. So we're going to use our product property first. We're going to break down the square root of 12. as the square root of 4 times the square root of 3. Not doing anything with that 5 square roots of 3 yet. And we get this 2 square roots of 3. Now notice the radicals are now the same. They're alike. So now I can combine them together. So what do? We look at the coefficients. So it's 5 minus 2. I'm just grouping them. And then square root of 3. So 5 minus 2 is 3. And then the radical is a square root of 3. All right, next one. Again, they're not alike yet. We have a square root of 3 and a square root of 27. We can't combine them together yet. But we have to first see if we can use our product property and simplify that square root of 27. So we get negative 2 square roots of 3, stays as it is, plus, and I'm going to use my product property, I'm going to break down 27 as the square root of 9 and the square root of 3. Well, that square root of 9, that'll become a 3. So again, the square root of 9 is 3. And then we have to multiply those two numbers. So 3 times 3 is 9. All right. Now we look. Are the radicals alike? Yes. I have a square root of 3. I have a square root of 3. We're good to go. We can go ahead and add these radicals together. So we're going to look at those coefficients in the operation. So negative 2 plus 9, there's the grouping, and then square root of 3. So negative 2 plus 9 is 7 square root of 3.